and VDS graph of MOSFET considering channel length modulation is. Here, channel length modulation. Here, without channel length modulation, the drain current is going to be constant irrespective of the variation present in the VDS. But because of the channel length modulation, the VDS is going to have an influence in the case of ID. That is, ID is equals to K VGS minus VT whole square. This is without channel length modulation. That is, lambda equals to 0. That is, lambda is channel length modulation parameter. If channel length modulation is not going to 0, 1 plus lambda VDS so lambda is not equals to 0 means VDS is going to have an influence on ID. So option B is correct.
Of output op amp shown in figure is, okay, we have to find the gain, okay, that is V0 by Vi ratio. Okay, since it is 0 volts, what is the virtual ground voltage at this point? Is also 0. Apply nodal analysis at this input side. Okay, so this is 0 minus Vi by, how many nodes are there? There are 2 nodes. Okay, this voltage we already know is virtual ground voltage of 0 volts. Let us take this node voltage as V. Okay, now write the nodal equations at the input side. So this is 0 minus Vi by R plus 0 minus V by R is equal to 0. From this I can say that Vi is equal to minus plus V, okay, into minus 1. So this is Vi is equal to minus V. Okay, now what is the nodal equation at this node V? This is V minus 0 by R plus V by R plus V minus V0 by R is equal to 0. From this I can write it as V0 is equal to 3 times of V. So what is V? V is equal to minus times of Vi. So this is minus 3 times of Vi. So what is gain? V0 by Vi is equal to, gain is equal to minus 3. So that is option D is the correct answer. Minimum number of NOR gates used to implement XOR is. Since NOR and NAND are universal gates, you can implement using these gates to convert it to any other gate. Okay, that is XOR, XNOR, or you can say AND, or okay, anything else you can construct using universal gates called NOR and NAND. Now, how many number of gates are required? If you see the construction of NOR and NAND, let us take this as a 2 input gate. Okay, first these two are given to a NOR gate. Okay, now this is the construction for NOR gates to convert into XOR gate. Okay, at this point of time you will get XNOR output, but what is the question? We require XOR. So at this point of time we will get XOR outputs. So how many are required? 1, 2, 3, 4 and 5. So option B is the correct answer. If the question is the minimum number of NOT gates used to implement XNOR, so what is the answer? Number of gates required is only 4. Similarly, the minimum number of NAND gates used to implement XOR is 4, whereas minimum number of NAND gates used to implement XNOR is 5. Okay. So option B is the correct answer.
Which of them are true? SRAM is used in cache memory. As it is true because SRAM is fast compared to the DRAM. And how do we design of a single SRAM cell consists of 6 transistors? It is true. And DRAM cell consists of 1 transistor and 1 capacitor. It is also true. In DRAM, the stored charge in the capacitor can be maintained only for short duration of time, because in DRAM the the data is stored in the form of voltages, because in the capacitor, which will lose its charge as a function of time. Hence we have to refresh it frequently. So all the statements are true. Hence Option C is correct. 085 microprocessor carry flag is affected by the following instruction. There are 4 instructions are given as the options. Increment is nothing but adding 1 to the LSB, so it's not going to affect the carry flag at all. Complement accumulator is also not going to affect the carry flag, as well as ending is also not going to affect the carry flag, because ending is nothing but a logical operation, it's not an arithmetic operation. So subtraction is the only instruction which will affect the carry flag, so option D is correct. Is equals to x of n into x of n minus 2, then the system is here. This system is time invariant as well as a not linear. So and we have to check for the stability condition. So if x of n is finite, the y of n is also going to be a finite. Hence it is option B is correct. Response of a system is given as, that is, y of n is equals to, for the impulse response for the system y of n is equals to maximum of x of n comma x of n minus 1 is. Here from the data itself, see, y of n is choosing the maximum of the given 2 signals. So it is a non-linear system. If it is a system is non-linear, we cannot describe it by its impulse response completely. So options are none of them, that is option D is correct. Which of these is the wrong statement? If delta x of t is convolved with the delta of t, x of t itself, that is statement A is correct, true statement. Comes to, if x of t convolved with the shifted impulse, then the signal is also shifted by the same amount, and x of t minus lambda 1 convolved with del of t minus lambda 1 is nothing but x of t minus lambda 1 minus lambda 2. So statement D is the only wrong statement, because all the 3 statements which E, B, C are correct. So option D is the false statement, hence option D is the correct.